Welcome to our review on transformers. First thing to know is that we're not talking about the robots in disguise. What we are referring to when we talk to transformers in physics is something that is going to increase or decrease the potential difference, and they're shown in the little diagram on the right hand side there. Now, the way in which a transformer works is that we will induce a potential difference when the magnetic field lines cutting a coil change. So there are three ways that we can actually bring about this change. The first one is that we can move the magnet or the coil. The second is that we can actually use another coil and turn the current in it on or off. And the third one is that we can use another coil with an alternating current. So any of those three things will actually change the field lines being cut within that coil. As we already know from our work earlier in this topic, that when a current flows through our conductor, it produces a magnetic field. Now, what we find is if you turn the current in that coil on or off, then you're going to change the number of field lines being cut each second, because we're changing the number of field lines present each second. If we use an alternating current, then what we find is that that current's constantly changing direction, and therefore the field lines are constantly being changed as well, leading to the production of its potential difference. So if we actually look at the structure of a transformer, what we actually have is this loop of iron. Now around that we've actually got two coils of wire, one on the left hand side and one on the right hand side. And what we find is that as the current flows through our primary coil on the left there, then that's going to induce this potential difference, which causes a current to flow within the iron itself, and what we then end up with is a magnetic field being trapped, if you like, within the iron core. So if we're actually applying an alternating potential difference across our primary coil, then we're producing an alternating current within that primary coil. So that then will generate the magnetic field, which is in that iron core that it's around. So what we actually find is that the magnetic field that's produced isn't going to be constant, it's going to be constantly changing, because an alternating current, remember, is constantly changing between the positive and the negative, which means the magnetic field will always be changing. So because of that, what we see is that that secondary coil on the right hand side, the blue one, that will then have a potential difference induced within it, because it's obviously cutting different field lines as the magnetic field changes. So we might be asked to carry out a calculation to do with transformers. Good news, we don't have to memorize this formula at all. So this one will be given to you should you need to use it. So the potential difference across the primary coil divided by the potential difference across the secondary coil is the number of turns in the primary coil divided by the number of turns in the secondary coil. So the kind of question they could give you here is one like shown below. Your mobile phone charger changes the mains potential difference of 230 volts to 12 volts. If there are 300 turns in the primary coil, calculate the turns in the secondary coil. So the first thing to do is extract the information you've been given. And I'd suggest the best way to do this, which is going to allow you to do a quick check later on, is by drawing the simple diagram there. So we've got the two very simplistic coils on each side. Then you put your potential differences alongside. So our primary potential difference is 230 volts on the left there. And then our secondary is 12 volts on the right. And then at the bottom, we've got N, which stands for the number of our turns of coil, which is obviously 300 for our primary and unknown, hence the question mark, for our secondary coil. So we've set out our little diagram there so that we can see our potential differences and the number of turns. The next thing we need to do is then rearrange that formula to actually give us the subject for what we need to work out, which in this case is the number of turns in the secondary coil. So to rearrange that, we'd end up with the potential difference across the secondary coil divided by a potential difference across the primary, and then we times whatever that answer is by the number of turns in the primary. So when you substitute in your actual values that we were given in our question, it ends up as 12 divided by 230 and then times by 300, which gives us 16 turns. And one thing to bear in mind is this must be a whole number. If when you've done your calculation it's not a whole number, you've gone wrong somewhere. Now, this little diagram we drew earlier is really useful at this point because it allows us then to have a look and see, is that right? Because what we will know in a moment is the difference between the number of coils on each side and what effect that has on the voltage. So having that little diagram will allow you to do a quick check when you have that bit of information to say, am I right with the number of turns? Is it what I expect? So always do that little sketch because it is just that self-check you can build in to make sure you've not made a silly mistake. So what we actually have are two types of transformer. We have step-up transformers, which will increase the potential difference, and they will always have more turns on the secondary coil compared to the primary. So the step-down transformer is the opposite. It's going to decrease the potential difference, and the way it does that is by having more turns on the primary coil than the secondary. So if you have that little diagram from our previous question, then we know that from the question itself, our mobile phone charger is changing the potential difference from 230 to 12 volts. So it's decreasing the potential difference, which tells us it's a step-down transformer. So that we know from our knowledge here that we must have more turns on the primary coil than the secondary. So once you've done your calculation, you can have a look. Is our answer actually less than the primary coil number? If yes, then you've got a step-down transformer. Chances are you've done it right. If, however, you ended up with more turns on the secondary coil than the primary, but the potential difference was decreasing, something's gone wrong, and you need to go back and double check what was wrong with your calculation. So just remember that step-ups will always have more turns on the secondary coil than the primary, and they increase potential difference, whereas a step-down decreases potential difference and has more turns on the primary than the secondary coil.